Namaste everyone. In this video we'll be solving a problem on kinetics. So we have a lift here which is weighing 12 kilonewtons, carrying a load of 20 kilonewtons inside of it, which is being which is moving upwards. Okay. So initial velocity is 0, final velocity that we require is 3 meters per second, and the distance in which this velocity is to be acquired is 3 meters. We have been asked to find what should be the tension, what will be the tension in this string over here. So let's go ahead and solve it. First, of course, we'll have to take the free body diagram of this lift along with this weight. Let's draw all the forces that are acting on it. We know that the friction will be acting on the side walls in the lift, and the average value of that has been given as 500 newtons. 12 kilonewton is weight, it's going to be acting downwards, and 20 kilonewton also is a weight which will act in downward direction. So now we have been told that we are required to reach upward velocity of 3 meters per second from rest. So that means the acceleration is acting in upward direction, and to balance that acceleration we'll have to apply inertia force in downward direction. Now, since the inertia is equal to mass into acceleration, we will first need the value of acceleration itself. That we have to find using this set of given data. We have a total of 3 equations of motion at our disposal. That is V equals U plus AT, S equals UT plus half AT square, and 2AS equals V square minus U square. So let us see which equation we can apply. We are interested in finding the acceleration. So since in the first equation we don't know the value of t, we cannot take it. In the second equation as well, we don't know the value of t, so we cannot take it. The third equation, all other values have been given. So this is the equation we need to use. Let's take that equation and substitute all the values that we know. S is 3 meters. V as well is 3, whereas U is 0. So acceleration will be equal to 3 square divided by 2 into 3. 3 gets cancelled and we get 1.5 meter per second square. Now that we know the acceleration, we can take the free body diagram of the lift and start applying equations of equilibrium on it. Because we have taken the inertia force as well, the object will still be in equilibrium. So let's take the sum of all vertical components. T is acting upwards, 12 kilonewton is acting downwards, and 20 kilonewton is also acting downwards. Friction force is acting upwards, and finally the inertia force is acting downwards. The sum total of all the vertical components has to be equal to 0 because the object is in equilibrium. We don't know the value of tension, so keep it as it is. The force 20 and 12 will give us 32, and this kilo we need to convert into newtons. So 10 power 3, if you multiply, we'll get it in newtons, plus 500 newtons minus inertia force, which will be the mass times acceleration. Now here mass will be equal to the total weight, which is 32 into 10 power 3 divided by acceleration due to gravity, that into the acceleration which we calculated as 1.5. So to find the value of tension, we need to send all these values to the other side. When we do that, their signs will change, and this is the value we get. Now since all the values we had converted into newtons, this value is in newtons. If you want, you can convert this into kilonewtons by dividing it by 1000. So now this is the value of tension in kilonewtons. So that's our answer. That's it for this video. Hope you have understood this perfectly, and till our next video,